Hey guys, so notes for lesson 7.8, solving polynomial screencast. So just start right in. In lesson 7.7, we wrote equations of higher degree polynomials by looking at their graphs. Often you won't be able to tell what the zeros are by looking at those graphs, but there is a pattern to rational numbers that might be zeros. So we call this the rational root theorem, and it helps you narrow down the values that might be zeros of a polynomial function. So this rational root theorem says if a polynomial has rational roots, they are in the form P over Q, where P is the factor of the constant term and Q is the factor of the leading coefficient. Okay, so I'll show you a couple of examples just using the rational root theorem, and then I'll show you how we're going to apply it to what the type of equations that we've been doing and how we're actually going to solve for them now. Okay, so after you have that copied down, let's move to example A. Find all possible rational roots of 0 equals 2x to the third plus 3x squared minus 32x plus 15. So let me just write down the equation here. Okay, first of all, it's important to note that this is in general form, so we have our highest exponent first and then on its way down. So 3, 2, 1, and then with no exponent. So that's got to be that way so that our leading coefficient is the correct number. So P, it said in the definition, is the factors of the constant term. So P, the constant term, is 15 in here, and Q, the leading coefficient, is 2. So what we do is we write factors of P. So factors of 15, 1, 3, 5, and 15. And then factors of Q, we have 1 and 2. Now not only do we have the positives of those, but we have the negatives as well. So we write that as plus minus. So go back and put in a plus minus in front of all of these so that each of these could be the positive or negative of all those factors. So, possible rational roots. Possible rational roots is the P divided by Q. So we have P positive or negative 1, so just write the plus or minus with the P. Positive or negative 1 over 1, positive or negative 3 over 1, positive or negative 5 over 1, and positive or negative 15 over 1. So that's all of the all of the number factors from P divided by that Q, divided by 1. Now we do the same thing for the denominator being 2. So I have positive or negative 1 over 2, positive or negative 3 over 2, positive or negative 5 over 2, and positive or negative 15 over 2. And you can go back and simplify these. Obviously, everything here that's divisible by 1, there's really no reason to write the divisible by 1. So every single one, we really just have positive or negative 1, positive or negative 3, positive or negative 5, and positive or negative 15. Then down here on the bottom, the 1/2, the 3/2, 5/2, and 15/2, we have to keep all of those because there's no other terms that are like that. So there are 8 possible rational roots for this equation that could possibly solve this polynomial. Okay? So let's look at example 2. So because that's all they were asking us to do. Find all possible rational roots. Well, those are all the possible ones it could be. Okay? So for number 2, same directions. We have a different equation. But again, we're looking for the same thing. So make sure that your equation's in general form, highest power of x first. So x to the 4th, x to the 3rd, x squared, x, and then nothing. So p in this case is 10, q is 1 because there's no number in front of x to the 4th, so it's just a 1. It's nice and easy when q is 1. So factors of p, we have 1, positive or negative 2, positive or negative 5, and positive or negative 10. And factors of q. Factors of q, why I like 1, just positive or negative 1. So, possible rational roots. All it is p divided by q, right? So all of these p's, 1, 2, 5, and 10, are all going to be divided by 1. And what happens when we divide by 1? We just get the numerator. So it's positive or negative 1, positive or negative 2, positive or negative 5, and positive or negative 10. And those are our possible rational roots. So, on the bottom of this here, we're going to make another note. Okay, I'm probably going to run out of room. Hopefully you don't. So we found possible roots, but how do we know if they actually are or not? So to find actual roots, plug in possible roots to the equation and see if the answer matches y equals 0. Okay? This has a name. I'm going to erase what's going on up here for now. This has a name, so this is called the factor theorem. Okay, that's what this is called, the factor theorem. So once we think we have possible factors or possible roots, we then take those and plug it into the equation to see if it indeed is a factor or a root by seeing if it actually matches 0. So what do I mean by that? Well, we said that possible roots were, let me erase not x equals. So possibles were plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So if we take, let's just take 1. Okay, so I'll take positive 1. So check 1. So what I'm going to do is plug it into the equation. So the equation was x to the 4th, so I'm going to check x equals 1. So I'll have 1 to the 4th plus 3 times 1 to the 3rd minus 11 times 1 squared minus 3 times 1 plus 10. So I just took the equation from example 2 and checked if 1 is a solution. When I solve this, I get 0. So what that means is x equals 1 is a root. Okay? So now let's try another one. I'm going to check 5. So check x equals 5. So now I plug in 5. 5 to the 4th plus 3 times 5 to the 3rd minus 11 times 5 squared minus 3 times 5 plus 10, and that equals 720. Which means x equals 5 is not a root. Okay? And that's all the factor theorem says. If you plug in the number and you get 0, then you're good. If you plug in the number and you don't get 0, then it's not a root. That's one way of checking. There's others, and we'll see that next. Okay. So, how does finding possible roots help to find all the actual roots of a polynomial function? The answer is we put the rational root theorem together with long division or synthetic division, what we learned last class, what we practiced last class, and the quadratic formula to find all the roots of a polynomial function. So it looks like this. It's a little bit involved, a little bit long. Stay with me. We'll do a couple of examples and then we'll practice the next time I see you. So we want to find the roots of this polynomial equation. We have the equation x to the 4th plus 2x to the 3rd minus 5x squared minus 4x plus 6 equals 0. So, first thing you should notice is this a 4th degree polynomial, which means we should have 4 roots. So we should have 4 answers. Okay? So the first thing we're going to do is use the rational root theorem to find all the possible roots that we could have, the possible rational roots. So remember, we have irrationals in the form of imaginary numbers and square roots. So the rational root theorem just finds rational roots. So this is step 1. So rational root theorem P is 6. So factors of 6 are positive and negative 1, positive negative 2, positive negative 3, positive negative 6. Q is 1. So possible roots there, positive and negative 1. So possible roots, possible rational roots. Again, this is kind of nice because we're just dividing everything by 1, so it's just positive or negative 1, positive or negative 2, positive or negative 3, and positive or negative 6. So, now that we know that, for step 2, we're going to use long division or synthetic division to test the roots. You may want to use a graph of the equation first to help you narrow down the possible roots by estimating your x-intercepts. So kind of like what we were doing before, except now not all of our x-intercepts, and maybe not even any of them, are going to be whole numbers. But we can still look at the graph to see if it can help us out. So let me pull up the graph here. Alright, so here's the graph of the first one that you have on your paper. And we're looking for possible roots. So we have 4 of them. We see that there's 4 roots. We have one here, which I don't know the number, one here, which looks like it could be x equals 1, one here, which I don't know what that is, and one here, which looks like negative 1, looks like x equals negative 3. So let's see if those are possibilities in what we have for our rational roots. So we do have positive 1 here. Oh, positive 1 is a possibility. What am I doing? That didn't really work out the way I planned. Positive or negative 1. And we have negative 3 being a possibility. So positive 1 and negative 3 are possible rational roots. So I'm going to use synthetic division with those to see if that works. So let me go on to step 2. I'm going to test x equals 1 because that's looked like it was a root back on the graph. So I test it, I do synthetic division. So here's the 1. The coefficients in my equation are 1, 2, -5, -4, and +6. So synthetic division, we should be pretty good at this by now, as we practiced it last class. So we bring this down. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -5 plus 3 is -2. -2 times 1 is -2. -4 plus -2 is -6. -6 times 1 is -6. And that gives me 0. So what does that mean? That means x equals 1 is a root, because we get the remainder of 0. So x equals 1 is a root. Okay, so 1 down, 3 to go. So on to step 3. Once a root is found, rewrite the new polynomial. So remember, once we find that root, this now is a new polynomial, but a degree less. So for step 3, we have the new polynomial being, instead of a 4th degree, we have a 3rd degree. So this would be 1x to the 3rd plus 3x squared minus 2x minus 6. So that's the new polynomial. Step 4, we're going to use, again, long division or synthetic division. I just went right to synthetic because it's quicker and I think easier, to test another root. So remember, back in the graph, it also looked like x equals -3 might have been a root. So let's check that out. So again, I'm going to do synthetic division. Now using, this is step 4, now using the coefficients from my new equation from step 3. So 1, +3, -2, and -6. And I'm testing -3 to see if it's a root. So let's go through and do this one. So we bring 1 down, that's -3. That gives me 0. -3 times 0 is 0. -2 plus 0 is -2. -3 times -2 is a +6 with a remainder of 0. So x equals -3 is also a root. So there's 2 rational roots that we found. Okay. So step 5, or into step 4, let me continue reading. It says to continue this process until you're left with a quadratic equation. Well, since we had a 3rd degree function and we just got a remainder of 0, this now is quadratic. It's a 2nd degree function. So we've made it through step 4. So now once we have a quadratic remaining, step 5 says use the quadratic formula to find the last 2 roots. So we're not going to continue with the division because I don't have any other rational roots. So quadratic formula is going to help us find the irrational or the imaginary roots. So step 5, I'm going to take that equation. So 1x squared, 0x, and -2. Okay, notice I just left in the 0x. I got it from here. Okay, so 1, there's the x squared, here's the x term, and the constant term. Okay, so quadratic formula says a equals 1, b equals 0, c equals -2. Write this kind of small going across because I have a little extra note for you down here. I know it's a little bit of a tight space. Quadratic formula, again, something we should be pros at by now. So we have -b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So continuing on, we have plus or minus because that -0 doesn't matter. 0 squared is 0. -4 times 1 is -4 times -2 is a +8 divided by 2 times 1 is 2. So square root of 8 is not a pretty number, but there is a special square root hiding in there. So that's the square root of 4 times the square root of 2 divided by 2. Square root of 4 is 2, so I get plus or minus 2 times the square root of 2 divided by 2. These guys cancel, so I'm left with plus or minus the square root of 2, and there are my other two roots, positive square root of 2 and negative square root of 2. So, I'm going to sneeze. Oh, it just went away. That'll probably sneak up on me a little bit later. Alright, so lastly, we write out the roots. So, roots. X equals, what did we find? We found 1, negative 3. So x equals 1, negative 3. Positive square root of 2 and negative square root of 2. So there is my final answer for this question. A long way away, lots of steps, but it said to find the roots. There they are. Now just one more note, remember, once you have roots of any kind, you can write the equation in factored form. A in this equation was just a 1 because the 1 was in front of x to the 4th, and now that you know these roots, we can put it in factored form like we were doing with 7.7. It's not asking you to do that, I'm just giving you another note that that's how you would do it if you needed. You could use rational root theorem and go through. Okay. All right, I know it's a little bit of a longer screencast than we're used to, but we got one more example I think it's important to go through. So here we go. Find the roots of the polynomial equation. Here we have 7x to the 3rd plus 5x squared minus 49x minus 35 equals 0. So, step 1, what are our possible roots? So I didn't mean to do that. P equals negative 35. So those roots are 1, positive or negative 1, positive or negative 5, positive or negative 7, and positive or negative 35. Q is 7, so positive or negative 1, and positive or negative 7. So the possible roots possible rational roots. We have the positive or negative 1, positive or negative 5, positive or negative 7, positive or negative 35, because those are all divided by 1, which just are themselves. Then we have positive or negative 1 over 7, positive or negative 5 over 7, positive or negative 7 over 7, and positive or negative 35 over 7. So let's take a look at these. Positive or negative 1 over 7 doesn't match anything we have. Positive or negative 5 over 7 doesn't match. Positive or negative 7 over 7 is really just a 1, which I already have here. So I don't have to worry about this one. I can erase that guy or just cross it out. And positive or negative 35 over 7, 35 divided by 7 is 5, so that's positive or negative 5, which is the same as this guy here, so I don't need this one either. So I really only have 1, 2, 3, 4, 5, 6 roots. We'll double it 12 because there's positive or negative. Those are my possible rational roots. So again, I could just start to try roots. If I don't want to graph it, I don't want to take the time to graph it, I can just start trying these roots. So for step 2, I could say, okay, well, I'm going to start synthetic division. I'm going to start with 1. So what are my coefficients? 7, 5, negative 49, negative 35. And I'm going to try 1. So bring down the 7. 1 times 7 is 7. That's 12. 1 times 12 is 12. Negative 49 plus 12 is negative 37. Negative 37 times 1 is negative 37, and this is negative 70. Well, this is not 0, so 1 is not a root. and then I would say, okay, not a root. And then I'll say, okay, well, positive 1 isn't a root, is negative 1 a root? And so now, not that you would have to erase, you just kind of cross out and move on. So let's say, okay, well, how about negative 1? So what are my coefficients? 7, 5, negative 49, negative 35. So bring down the 7 times negative 1 is negative 7. There's negative 2 times negative 1 is positive 2. It's negative 47 times negative 1 is positive 47. And when I add them together, I get 12. Again, not 0, so negative 1 is not a root. And you can continue doing this until you find a root. Or you can make the graph and estimate. Okay? So let's look at the graph, because I don't want to have to do this possibly 10 more times to figure out which root is an actual rational root. So let's look at the graph. Here we go. Here are our possibilities. And I have them labeled. This is supposed to be a 0. It said the root. I don't know why it printed funny. So we have negative 2.65, negative 0.714, and positive 2.65 are all possible rational roots. Now remember, a calculator will round, so we don't know if these are actual rational roots or if they're rounded square roots. So let's go back and look at our possibilities. Well, 4 of our possibilities are whole numbers, and our graph does not intersect at any whole numbers. So none of these possible rational roots are going to be actual roots. They're out. So let's try 1/7 and 5/7. In order for me to tell that, I'm going to need to know what 1/7 is as a decimal rather, and what 5/7 is as a decimal. So when I do 1/7 on the calculator, I get 0.1428. Now remember, that could be positive or negative. That's not one of my decimals. Or 5/7 is 0.714, and it continues to 8, but the first 3 numbers exactly match this root here. Again, this is positive or negative. Looks like because this one's negative, I'll be taking the negative. So it looks like negative 5/7 is my root, my only rational root. The 2.65 is not rational, so I'm going to have to solve that a different way. So let's try the synthetic division with the root that I just located on the graph. So negative 5/7. So back to here, I'm going to erase this guy here. Again, you can just cross out, I just don't have enough room. So let's do negative 5/7, and we'll do the rational root theorem there. So the synthetic division. So bring down the 7. Negative 5/7 times 7 is negative 5. This becomes a 0. 0 times negative 5/7 is 0. Negative 49. Negative 49 times negative 5/7 is 35. And add these up, there's my 0. So x equals negative 5/7 is a root. Finally, I got one. And that's so important because now this here I can rewrite as another equation. Since this polynomial started in 3rd degree, this polynomial down here is going to be 2nd degree, which is quadratic, and I'm almost at my solution. So for step 3, I'm going to rewrite, and I have 7x squared plus 0x minus 49. By the way, b doesn't always have to cancel out. You're not always going to get a 0x in the middle. It just so happens that the 2 examples I picked, we do, of course. Okay, so here's my new equation. I don't have to do synthetic division again because I have my quadratic. So I just simply use quadratic formula. So it's like skipping to step 5 also. So A is 7, B is 0, C is negative 49. So we have 0 plus or minus the square root of 0 squared minus 4 times 1 times negative 49 divided by 2 times, 7, not 1. So we get plus or minus the square root of 1372 divided by 14. So square root of 1372 can actually be broken into the square root of 196 times the square root of 7 over 14. Square root of 196 is 14 times the square root of 7 over 14, so that'll cancel, and my answer will just be plus or minus the square root of 7. There are my other two roots. Remember back at the beginning I said we needed 3 roots? There they are. I have plus square root of 7, minus square root of 7, and negative 5 over 7. So I can write this in factored form if I want. And I know my roots. So the roots are what they're asking for. X equals negative 5 over 7, square root of 7, or negative square root of 7. Factored form of this equation would be y equals, my a term was 7, and then I'd have x plus 5 over 7, x minus the square root of 7, and x plus the square root of 7. Again, it's not asking for factored form, it's asking for the roots, but I just want to point out that that's another way we could write it. Alright, so I know this was long, I know this was a lot. Like I said, we'll have a bunch of practice with this because it's going to be on your quiz, it's going to be on the test, it's going to be on the final, and it's stuff that will definitely help you next year if you're going into pre-calc. So, good stuff to solve some polynomials, and I will see you in class.